Welcome at this session. I'm Daniël Wedema. I'm working for the Volksbank, and during this session, we're going to dive into the distinctions between front-end and back-end. I hope at the end of the session, both back-end developers will start to like front-end, and front-end developers will start to like back-end. So I'm going to share my experiences at the Volksbank with both sides, and let's see how it works out. I like interactive sessions, so if you have any questions during the talk, just raise your hand. I'll give you a moment to ask your question, and then we can go forward. So first off, let's say we have three categories of developers: the front-end developers, back-end developers, and full stack. Now, by a raise of hand, who considers themselves a front-end developer? So a little bit. Who considers themselves a back-end developer? Okay, majority probably. Who thinks of themselves as a full stack developer? Okay, nice. Good, good. Then I think this presentation is for the right audience, because the main goal is to convince back-end people that front-end development is not so scary anymore. Now, I am a back-end developer by origin. And this is a little bit the sentiment that I used to have. So I was trained as a Java developer. I also had some C++ and C training. And then you talk to other backend developers. It's like, okay, Python, cool. Kotlin, I see what you're doing. C++, cool, you have objects, object-oriented programming, you're cool. And then I look at front-end development, and there's HTML. It's like, it's not programming. So there's all these power ranges combining their powers. And then there's this Teletubby. But when I joined the Volksbank, I started out with some back-end Java applications, and then I slowly moved on to the front-end platform. So actually now, I am a front-end platform developer. So I am a Teletubby right now. And the goal of this presentation is to convince you that actually we are power Teletubbies, just like the Power Rangers. So the gap is closing between back-end and front-end. So let's talk a little bit about the Volksbank. Maybe this brand is not that familiar to you. Actually, the Volksbank is not one bank. It's a family of different brands. So one of the brands that we represent is the ASN Bank. So their focus is to spend their money wisely. So look for environmentally sound solutions. Then we have BLG Wonen. This is the bank that focuses on people who want to buy houses. So it's mostly mortgages focused. Then we have Regiobank. It's also one of the family of brands. Their concept is to basically get away a little bit from the big cities and focus more on the small towns. So they have local people in the small towns who can sell products for the Regiobank. So they know the community, they know the people, and they can give personalized help. And then there's SNS, which is basically the bank for the common people. So more human, more normal. Now imagine if you work at an IT department and you have one business unit. Keeping this business unit happy is already a huge challenge. So you have all the business requirements and you have your IT department trying to solve those requirements. Now at the Volksbank, we have one IT department, but we have 4 independent business units. So you can imagine that this creates a kind of like a challenge, let's say like that. So we don't only have one business to keep happy, but we have 4 of them, which are independent, and all of them, they have their own identity. So let's look at these 4 banks, and let's look at the IT department. So we have different developers working at the IT department, and they are focused on different skills. So it's a very generalized, but it's more about the concept. So let's say you have developers which are back-end developers. They're good at some Java applications. Other people are more experienced in SQL. And then we have a content management system, which used to be the only presentation layer that we have. Now, if you have one IT department and 4 business units, how are you going to group this into functional teams? One way to do it is to align your teams along the different brands. So you create a team which is focused only on SNS. They listen to what SNS wants, and they listen to their business requirements, and they build something in the CMS, they buy or build some Java applications, they run their own databases, etc. This kind of works, but there is a lot of duplication between these different IT departments. For example, if you're a customer at ASN, you probably need to fill in the same data if you're going to move from address. So there is going to be duplication in these applications. Furthermore, if you solve a problem here, So if you solve a problem here, it might be that one of the other brands is also interested in the solution. So how do you share knowledge and solutions between these different brand teams? So another way to do it is to say, okay, let's see if we can put all the different skill sets in one team. So you combine all the Java knowledge into a Java team. You combine all of the database knowledge, and you put this in a database team. This works in sharing knowledge, but now if you want to build one application, you need to basically divide the work among different teams. So this creates a tight coupling between the different teams. So this is also not very ideal. This is a solution that was applied a long time ago in the IT department at the Volksbank. The more recent solution is what we apply here. And I think the core of this solution is to have a single platform, multi-brand solution. So let me explain a little bit. The entire IT department is divided into basically two layers. There's the platform teams, and there are the value teams. The platform teams, their only focus is on tooling and techniques. So they make software, they make applications, but the consumers of their software are other developers, and they are developers in the value teams. The core focus of a value team is a specific requirement from a customer of the bank. So for example, there's one team that is focused only on mortgages. So their domain of expertise is mortgages, and they can use the tools provided by the platform teams to deliver this value. One of the restrictions on the value teams is that they are never ever going to create a solution which is only applicable to one brand. So mortgages, its main focus is BLG, but also SNS Bank and Regenbank, they sell mortgages. So if you're going to build a mortgage application, it needs to be a multi-brand solution. So we created this setup for the different teams. And the main focus where we solve the multi-brand solution is in this platform team. So there's a continuous delivery team. There is a Pega team for there's a CMS team, so that's the updated. We have Experience Central. There is an Angular team for the front-end platform. There is a UX team. They use mainly Zeppelin. Then there is a login and session manager. And we have Spring Boot REST APIs. So the UX team, their main goal is to solve the multi-brand problem. So what the UX team does is they design components for the front end. And the way it's designed is that there's a consistent look and feel, but every brand can differentiate a little bit, mainly in color, roundings, borders, this kind of things. But everything else stays equal, which means that if we're going to build a component like this, a date picker, we only need to build it once, the functionality of it, we only build it once, and then afterwards we can apply different style sheets to create a multi-brand solution. Now, if you have a library of multi-branded components, and you have a value team that applies those components to an application, you automatically get a multi-branded application. So they don't even have the choice anymore to build an application specifically for one brand. They use multi-brand components, so they get multi-brand applications. Everything else is completely, basically white label. So that's the single platform multi-brand solution. Then we have a lot of value teams. So these are the value teams, one for mortgages, one for payments, insurances, savings, your customer data. They build business processes. So you move from address A to address B. That is the value team that registers your customer data. So they build a business process. So they define which data you need for the process and build an Angular application on top of it. So we have a UX team. They design multi-brand components. Then we have value teams which use those components to model different business processes. So one for transactions, one for your debit accounts, one for your debit cards, etc. These processes can range up to like 100. So there's basically 100 processes that a customer can do to mutate data, to do a bank transaction, to change address, to change your name, etc. However, having 100 independent applications running in production is not very maintainable. So what we do is we decouple the process from the channel. So we define, in this case, 4 channels. There's a retail channel for a customer who's not logged in. There is a mobile channel where we use a web container. There is the customer channel, so if you are a customer and you log into your banking environment. And then there's the partner channel, so that's, for example, what Regenbank is using. So we decouple the channels from the processes, which means if a value team models a process, then afterwards we can decide in which channel to expose this process. So we might have 100 processes, but in the end we only have 4 or 5 single-page applications, which are the channels running in production. So this reduces the complexity hugely. Then this is the implementation. So like I said, the components are designed by the UX team. We have a core team of the front-end platform which builds those components. Then we have the value team which assembles those components into a process. And only afterwards, we basically build the application 4 times. So we have a white label functionally application with 4 style sheets applied to it. So styling is one way where the brands can differentiate. Content is another one. So the way you address your customer, you can differentiate between this as well. So that's all front end. So now let's see where does the back end come in and how do I think is the gap closing? So like I showed the image before, you have backend, which are the Power Rangers, and then you have the front end. Well, HTML is the Teletubby. CSS, not much better, it's still not a programming language. And then there's JavaScript, which is an actual programming language, so maybe JavaScript can close the gap a bit more. But the front end, especially for me as a backend developer, when I first came to the front end, this is what you find. So there is a huge amount of tools and libraries and new stuff to learn. I'm thinking, why? We have the Trinity, HTML, CSS, JavaScript. Why do I need all of this to actually get something working in the browser? Where are the good old days of just, a blank HTML page? So this does not look very good for the front-end field for me as a back-end developer. Like, this scares me away. And then there's another thing, which is the issue of a typed language. So I, as a Java backend developer, am very much used to having typed variables. So you have a variable, it has a specific type, and I can never ever assign something else to that variable. Now if you look at typing, there's the 2 axes where you can divide languages among. So there's dynamic versus static, which basically means, am I going to check the types at runtime, or am I going to check the types compile time? Which basically translates to, will you find runtime bugs or will you find compile time bugs? Well, I prefer compile time bugs. And then there's the issue of strong typing versus weak typing, which is the other axis. So JavaScript notoriously allows the string 120 to be compared to the number 120 and just say, yeah, they're equal. I mean, sure, me as a human would understand this, but I would never want my computer to think this way. So I'd like to have strong typing, because it prevents bugs, and I'd like to have compile time errors, because it prevents my users from finding this. So Java was in the right corner, and JavaScript never was. So we have HTML and CSS, which are not really programming languages, and then we have a programming language, but it causes runtime bugs and does some weird behavior. So this does not look very good for the front-end field. So yeah, they are languages, but they are not even anywhere in this quadrant. But then, so that was JavaScript, which is formalized in ECMAScript, which is called ES5. So ES5 is ECMAScript, which is supported by all the major browsers. So even if you take IE9, IE10, it will run ES5 perfectly fine. But it's a static, a dynamic language with weak typing. Then came the update of ECMAScript, which is ES6. They introduced classes and modules, which is something that I, as a Java developer, am used to. I'm used to import code from another module, and I'm used to defining classes with well-defined behavior. So I can apply object-oriented programming, for example. So nice, this is the future of JavaScript, starting to look a little bit more like a Java backend. But then you go to the website, can I use? And you can see all of the front-end features and ask, can I use this feature in one of the browsers? Well, of course, there's always IE, and even up to IE11, ES6 is still not supported. But then, and I think this is the real revolution in front-end world, and that is something called TypeScript. So TypeScript is adding to JavaScript what always has been missing. So JavaScript is fine, you know, if you just want to do some scripting. So you have a menu, you click on it, and it needs to expand. That's it, fine, use JavaScript. There's great libraries like jQuery, you can use it. But it's not meant for enterprise scale applications. Enterprise scale applications are still in the backend, where you have strong typing, compile time errors, etc. But now we get TypeScript. And TypeScript is a superset of JavaScript. So I can write almost like I write Java. There's an actual compiler, which is something that we also did not used to have. So I can have compile time errors. And it adds type information to all of my variables. If I compile it, I can compile it back to ES6, if I know, for example, I'm not going to run IE11, or I can even choose to compile it back all the way to ES5. So it will support IE11. So this, for me as a backend developer, makes me happy to come back to the front-end world. So the way to solve basically enterprise scale front-end development, you need strong typing. Without strong typing, you will run into issues sooner or later. Then I showed you the slide before with all of the tooling. Well, there's actually a way to solve it. Take the latest Angular platform. They will manage all of those tools for you. So pick one of the big platforms, and it will run all of the tools for you. So I have a little bit of a demo for this. So what do we do at the Volksbank? So we have the UX team, like I said before. They design multi-brand components. Then we, in the front-end platform, we transform the designs to actual implementations. So before, and this is called the guide. And the guide is a live view of all these components that developers can use. So I showed, for example, the design of a date picker. Now in the guide, I can look at the actual implementation. So first we have design, and this is the implementation. And I can see an example of a date picker, and it's fully interactive in the guide. So I can play with it, see what it looks like, and interact with it. There's different examples. So you have a date component, but you can configure it in different ways. The documentation from this component is extracted into JSON, and we parse the JSON into this application called the guide. And it shows you the different ways you can configure this component. So you can give it, for example, a date filter function to disable certain dates. So let's see a filter example. And you can see that, for example, the weekends are not selectable anymore. So this is the actual example, and you can have it multi-branded as well. So if I click ASN, it will load the guide as an application completely anew, because it needs to apply new style sheets and new content. And you can see it's exactly the same functionality, but different style sheet, so different colors, different content, different lines, etc. Then, if I'm building an application and I want to use this component, I'm not only interested in what does it look like, how can I interact with it, I want to actually see what do I need to do to get this to work. So it shows you the template that is used for this demo. And it shows you the script that is used for this demo. So if I, as an application developer, use this piece of script, I use this piece of template, I will get this functionality that I just saw in the demo. Now, there are quite a big number of components that are designed and implemented. I think we have about 100 components that can be used by the application developers. So let's look at another one, which is, for example, the account selector. So here again, there's an example. If you have multiple accounts, it will look like this. If you have only a single account, there's nothing to select, so it collapses. Now, let's try to use this component. So I'm going to build an application, and I want to use this component. So what can I do? I take this piece of code, I copy it, now here I have just an empty component, an empty class that I'm going to fill with these components, just to see what does it do. So here's an empty template that's based in the account selector. Now, what do I need to do to get it to work in the script? So here it tells me you need to have a public field, which is properly typed. So you need to have a public field with the accounts you want to display, and you have a public field which is of type form control that is going to hold the validation of this component. Now this I can also just copy and paste back. So there are modules, like I said, which means you can actually do imports, which is exactly like you would do in Java. The syntax is a little bit different, but the concepts are exactly the same. So I want to import the type definition of this field. I want to import type definition of this field. Okay. So the code is being watched. Every time I change something, the Angular compiler will actually start compiling this. And I have added an example, TEQnation example. And here it is. So all I did was just copy pasting these components, and I can get it to work pretty easily. Now this example is using a fixed list of accounts. So in production, what I would like is to have a backend API that will call, for example, for the logged in customer, give me the accounts that this customer actually has. So I want to change this hard-coded list of accounts to something which is dynamic and depends on the logged in customer. So what I need is a resource, which is a service that will call the actual backend. Now, we have a resource like this, and the way we get it into our class is by dependency injection. Dependency injection is also something that's very well known in Java world. So there's two types. You can either do dependency injection on a field, or you can do dependency injection in a constructor. So what I want is an account resource, and it's injected based on type. So I import it and that's it. Now I can start using it. I even have access modifiers, like you normally have in Java as well, to make sure that I can only use it inside of this component and nobody outside of the component can start using it. Now here's a fixed list of accounts, so let's get rid of this and instead set this field through the account resource. So you get autocomplete, because everything is nicely typed, so I don't have to guess what's the name of the method. I don't have to go to some documentation somewhere to guess the name of the method. I can just use my IDE to properly get these fields. This is an observable, which means you can use asynchronous behavior. So if I subscribe to this field, I get my actual accounts. And now I want to assign this to the public field. So let's get rid of this as well. Now it starts complaining. And I like this, because this is a compile time error instead of a runtime error. So, like this. Complaints here. So I get my account from the backend, which is of type account array. But what I'm going to use in my component is a different class. It's a different type. So my type information is actually helping me here. It says, well, you have two objects. They look pretty much alike, but they are not the same. So you are going to run into issues. It even tells me which field is missing here. So it tells me what you get back from the backend does not have the property name. And that's why I cannot assign it now to my display account. So what I can do is to actually map each of these accounts and give it the extra property was missing, name. And I get nice autocomplete, so I just need to type a few letters. I know that the backend gives back an object with a field called product name, and the component for selecting accounts expects a field called name. So let's just assign it. This is a nice property in the front-end world called destructuring. So here I'm creating a new object. I'm destructuring all of the fields of the old object, so it gets those fields. And I'm just adding a new field called name, and I assign the value product name there. So now instead of having this fixed list of accounts, this is actually coming from a backend. Well, sort of from a backend, because in local development, I don't have an actual backend. Instead, what we have is a local mocking server. And here I can switch different simulated responses from the backend. So I can actually test what will happen to this component, or what will happen to my application, if the backend sends back something else. So if I, for example, take only saving, I'm expecting to only get savings accounts. Well, in this case, there's only one. And the component, as promised, will in this case not show a selector, but only display text. So it's very nice. So me as a backend developer, I'm starting to get very happy. So this looks a lot like what I would do in a backend. I have strong type support. I have compile time errors. I still don't know anything about basic HTML and basic CSS. But I didn't do any basic HTML. I just copy-pasted this thing, which was documented properly. I don't need to add any CSS classes, because that was already done for me. So if I'm a backend developer, and I'm in one of the value teams, and I need to build front-end applications, I would love to do it. I would not be scared anymore of CSS, HTML, or whatever. Now, what would happen if the account, for example, returns an error? Does the component deal with it properly? Well, not really. So what you could do is say, well, let's add a notification in that case. Only show it if there is an error. Now, normally we would put the content in the content file so each brand can manage it themselves. So now I need to set a public error field to trigger this notification. So let's add a public error. It's a Boolean. By default, it has the value false. The way observables work is you can pipe them to manipulate them, you can catch the error, in which case I'm going to say, yes, there is an error, and I need to actually return something. So if I return a proper value, it's a handled exception. If I keep on throwing the error, it's an unhandled exception, and it will stop the flow. So let's throw the error, because I don't want to do any mapping anymore. Okay. Now, if I select my get accounts, it was still recompiling. So let's say it returns a backend error, and I can see, okay, this is the way it works. So if I'm building an application, I can search for the components I want to use. I can copy-paste little HTML snippets, and I can start programming away almost the way I was used to in a backend, with full support from IDE and full support of the compiler. So this is starting to look a lot more like backend. So I'm not dealing anymore with CSS, that's been handled for me. I'm barely handling HTML, but it's very understandable, and I'm mostly dealing with typed code. So that's one thing. I think that's one thing where the front-end world has learned a lot from the backend. But actually, now I've been working more and more in the front-end department, I'm starting to notice a few things where I think the backend might learn something from the front-end as well. One thing has to do with folder structure. This is the classical Maven approach to folder structure. So if you have any Java project, this is what Maven tells you to lay out the folders. So the main distinction is, for example, do you have implementation code that actually goes to production? You put it in source main Java. If you have a unit test that describes your implementation code, you put it in source test Java. It's a choice you can do. This is very common in the backend. So almost all projects do it this way. If you have a filter, put it in source main filters. If you want to describe the specifications, go to a completely different folder, source test filters, and describe your filter there. Fine, this works. It has been working for a long time. Then if you go look online for most of the front-end projects, they will advise a kind of similar setup. I think this was heavily inspired by the way Java does it. So they say you have implementation code, put it in source. If it's of type JavaScript, which was the old days, put it in a folder JavaScript. If it's a controller, put it in a controller. If it's a service, put it in service. Then similar to Java, if you want to describe the specifications, go to a completely different folder called test unit, and then you have the same structure again. So very much inspired by the Java world. This is a tool called Gorse. You can apply it to your application, and it will show you the folder structure. So each line is a new folder. Each dot is a file in that folder. The color of the dot is the type of file. Now in the backend, almost all files are either Java or XML, so you basically have two colors. In the front-end world, you have a lot more types of files. So you have HTML, you have JSON, you have CSS. Well, the list goes on. If you apply this folder by structure, which is the default in the Java world, this is the kind of image you get. So on root level, all folders are separated by type, primarily by language. And I would characterize a project which is structured like this by this image. So if you look at any folder, all type of files in that folder will be the same. So very homogeneous. This reminds me a lot of the way the development teams initially were structured as well. So they would put all developers of the same type in the same team. Well, that's basically what happens here as well. You speak the same language, you go in the same folder. It works, but this is not a very scalable solution. If I will join the team that builds this application, and I'm going to add a feature, I will probably need an HTML file for the feature, probably some controller that controls the HTML. I probably want to describe the controller with a specification file, which means I need to add a file here, somewhere in the test folder, somewhere there in the controller, another folder for the HTML. So all those files describe the same feature, but they are completely separated in my folder structure. So this is not scalable. If I want to restructure some of my implementation code, and I think a lot of Java developers have this as well, you take a folder in your source folder, you put it in another directory, then the unit test folder, you have to do basically the same thing again. This to me also shows it's not very scalable. So another approach is the domain-driven approach. And it means on root level, please don't look at the type of file. The only thing that matters on root level is what is the topic that the file is about. This is the same thing if you structure your organization with different teams. Don't look at the skill of your developer. So it doesn't matter if he's a front-end developer, a back-end developer. It matters what's the domain he's structuring. Is he a mortgage developer? Is he primarily speaking about mortgages? If they are, and you have different skills talking about the same domain, they all belong in the same folder. So if you use domain structuring, and this for a Java developer is very uncommon to put your specifications right next to your implementation in the same folder. In the beginning I thought, wow, that's scary. How am I going to make sure that my specifications don't end up in production because I don't want them there? Well, you have tooling. Very easy to filter out those files. But I love this structure because if I change anything in my implementation, I don't need to go all the way through my navigation tree to find the specification and change it. This is the old structure, and well, you can already see, this is organized, this is messy. And this is still what Java does, which to me feels like a messy structure. So if you apply a domain-driven design, this is more or less the kind of tree you find in your applications. The structure of this tree is determined by the structure of your domain, which is the way it should be. Now each folder, which could be seen like a team, is talking about the same topic. They use different tools to describe the topic, but they all belong together because they talk about the same topic. So I would love to see Java to apply this kind of principles a little bit as well. So you could put your specification files right next to your implementation files, and they would be much easier to find. So then one other lesson that we learned from creating a front-end platform. We have the classical platform layer in our organization and the value layer, which is symbolized here. So we are the core team, we are Angular experts basically, and we support a lot of value teams. This as well is not a very scalable model. Because we are the single source of truth, the single source of knowledge, we spend a lot of time supporting these value teams. However, if you look at the combined knowledge of all the value teams, they together know more than any individual member in the core team. So why not let them help each other? So we've implemented this model. We use, for example, Slack. So if you have a question about the Angular platform, please don't ask us, the core team, ask the community. And in general, the community knows more and answers much faster because there are a lot more of them. So the lessons learned. If you have multiple brands, don't create different IT teams for each brand. Try to go for the single platform, multi-brand solution. If you get scared from the huge amount of tools that you need to build front-end, pick a platform that manages a lot of these tools for you. So Angular is a great way to do this. Please step away from JavaScript. JavaScript is fine if you just want to do little scripting. If you have a menu and you want to navigate it, it's fine. If you want to do enterprise scale front-end applications, pick a statically typed language. It gives you so much more support. Apply structure by type. And I showed you the example for the code, where it's much more maintainable, but also apply it to people. If they talk about the same topic, put them in the same team. Invest in the community. This is also a very important concept that we applied You get the best knowledge, you get the fastest support, and you get a lot of cooperation between the different teams. So that's the lessons that we learned at the Volksbank. And I want to thank you for your attention.